Converting fractions. Converting fractions is where we change how a fraction looks by how we cut it up. So we can have a fraction that we decide to cut into more slices or more pieces. Or we may have a fraction that's cut up into many pieces and we glue some of those pieces together so that it is larger pieces. But when we do this, the fraction amount stays equal and unchanged. So what we're actually exploring in this video clip is how to create your own equivalent fractions. And if you're not sure on equivalent fractions, I'd refer you to the other video clips that introduce this idea. So very simply, we're going to start with one whole as a bar or rectangle shown on screen, and we're just going to cut it in half. And we're going to explore this equivalent fraction idea initially, but we're going to demonstrate how you can direct which fractions or which equivalent fractions you can create or convert your fraction into. So let's just start off by colouring in 1/2 in light blue, and we can see that that's recorded as 1 as the numerator and 2 as the denominator, as shown below. And now we can start thinking of how can we convert this to a different equivalent fraction. So first of all, we can cut the 1/2 into 2 equal parts. Now we know that that is going to create 2 equal fraction parts. However, if we look at the entire shape, the remaining half is large, so I cannot make thirds here. So even though I've got 3 pieces, they are not equal in size. So thirds is actually an impossibility for 1/2 as an equivalent fraction. However, if I cut the remaining half in half itself, now I have 4 equal pieces. 2 of those are coloured in light blue, so I have 2 quarters as an equivalent fraction that I've just converted my 1/2 into. So the key here is that I can cut up as many times as I like my fraction piece, as long as I cut up every other fraction piece by the same amount. And that will create a new set of smaller yet equal sized pieces, so a new fraction type, and a new number of that fraction type that I have as well. So in this case, my new fraction type is quarters or fourths, and I now have more of them. I have 2 of them rather than just 1/2. And I can keep going with this process. So I'm just going to move my 1/2 over to the side as well as my 2 quarters, and let's cut again. Here I've put 1 cut into the first quarter. So if you look on the screen, I have now 2 small fraction shapes and 3 larger fraction shapes. So it's not a true fraction. Here I just have unequal pieces. So fifths, although I've got 5 pieces here, is an impossibility. I cannot make fifths if I'm using 1/2 or 2 quarters. If I keep cutting, now I have 4 equal pieces in light blue. So I'm onto something here. I know that I can make 4 equal pieces in light blue. So I'm hoping, of course, that I can continue this on and discover the fraction type that will work. But for the moment, it's not a true fraction on screen because the white pieces are way too large and unequal. So I have 4 equal pieces, so I need to make sure that those white pieces are cut just exactly the same. And if I cut those in half as well, I will find that I will have 8 equal pieces, 4 of which are coloured in. So 4/8. And again, the process can continue as shown. So here I can cut up each piece in half again, and I'll end up with 8 equal pieces. But of course, it's not 8/12 because those remaining 4 pieces are not the same size, so they need to be cut up exactly the same as well. Now I've got a proper real fraction, and it is 8/16 because there are 16 pieces in total. So I can just move those over to the side there so I can see quite clearly what I'm dealing with. And now we're just going to return back to the original half to explore what other equivalent fractions we can convert 1/2 into by the way we go about our cutting. So we just went through a whole range of examples, 1/2, 2 quarters, 4/8 and 8/16, based on cutting each fraction piece into half each time we went along. This time, let's explore cutting each piece into thirds or into 3 parts. So we'll start off cutting our half here into 3 equal pieces. Now, of course, I've got 4 pieces on the screen, one of which is very large. So quarters aren't going to work if I want to have 3 as the numerator or 3 pieces as my fraction. So since I've cut my half into 3 equal pieces, I need to cut the other half into 3 equal pieces. And if I do that properly, I can see that I now have 3 pieces out of 6 equal pieces, so it's a true fraction. It is 3/6. So I just record my 3/6 down below there, and I've just tidied up how I cut that remaining half a little bit so that it looks more even, as it should. Now I can continue this process again. I can cut each of these pieces into half like I was the first time around, or I could continue cutting them into 3 pieces. The possibilities are limitless. So just to show you very quickly, if I cut each one of these into half as such, suddenly I would have a new fraction, and the fraction would be 6/12. Okay, so I've just switched back to the strategy I was using earlier by cutting each piece just into 2 pieces rather than 3. Or if I switch back to the 3/6 before I decided to go back to cutting into 2s, I can continue with the cutting into 3s pattern I was doing, as shown, by cutting up the first piece into 3 pieces, and then I can cut up the next fraction piece into 3 pieces that are equal, then the next piece into 3 pieces, and of course the other pieces into 3 pieces, equal pieces as well. So instead of halving them all, I am thirding them all, and therefore I still end up with equal sized pieces, and this time I end up with 9 pieces out of 18 that are coloured in, so 9/18. So you can see that I can go about this infinitely. So I could decide to cut up each piece into halves, or into 2 pieces, or into 3 pieces, but there's nothing to stop me picking any number I like. So I, of course, could decide to cut this into 5 pieces. And so now I've got 5 equal pieces in that 1/18 that I've cut up. But of course, if I cut up every other piece into 5 and so on, I would find that they would all be equal. So therefore I'd have a new larger equivalent fraction to a half. In this case, just for the purpose of the example, this would have made 45/90. So with all these equivalent fractions that we can convert 1/2 into listed below it, we can see that we can also work our way backwards. So with 45/90, which was so large, it can have all those pieces stuck back together to create just 1 out of 2 large pieces, or 1/2. Now the process of going backwards or making the pieces larger is called simplifying, and this is perhaps a slightly more difficult skill, which will be explored in the next video. However, I just want to make sure we're noticing some patterns and ideas of how we can convert fractions. So we're understanding that we can cut each piece into 2 pieces or into 3 pieces, as shown in this clip so far. But of course, I could also cut each piece into 4 pieces, as shown, or 5 pieces, as shown, and so on and so on. So what's actually happening is I have all these countless possibilities of how I can cut up a shape or a fraction shape to make it into larger amounts of pieces, which of course are getting smaller and smaller as I cut. So what's actually happening with a half or 2/4 or 4/8 is I can always just cut every piece into half and make it smaller, or every piece into thirds or quarters. So I can actually keep cutting and cutting and cutting. So the possibilities of any fraction is just a multiple of that fraction. So if we look at 1/2, as shown below, it has a denominator of 2. So that means I started with 2 pieces. Now, as we've discovered, those 2 pieces can be cut as many times as we like. So in the picture that we have on the screen currently, we can see that I cut every piece into 5 pieces. So the first half I cut into 5 pieces, and the second half I cut into 5 pieces, which gave me 5/10. So yet another one. So all of these are possibilities. they are all multiples of 2. So what I mean by that, 2, 4, 6, 8, 10. And the reason is because I can start with my original half and cut it just into 2 pieces to make quarters. Or I can cut it into 5 pieces to make tenths, as shown on screen. I can pick any number of cuts for infinity to do. So every factor of 2 will work. What I can't do is make thirds, as we saw earlier, because I can't cut 3 equal pieces and still have it be 1/2. Not for this particular example.